Day 759 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2144, minimum cost of buying candies with discount. The difficulty level is easy, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. A shop is selling candies at a discount. For every 2 candies sold, the shop gives a third candy for free. The customer can choose any candy to take away for free as long as the cost of the chosen candy is less than or equal to the minimum cost of the 2 candies bought. For example, if there are 4 candies with cost 1, 2, 3, and 4, and the customer buys candies with cost 2 and 3, they can take the candy with cost 1 for free, but not the candy with cost 4. Given a zero-index integer array cost, where cost of I denotes the cost of the ith candy, return the minimum cost of buying all the candies. Alright, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input cost equals an array of integers 1, 2, and 3 that represent the cost of each candy. The output is 5. Explanation says we can buy the candies with the cost 2 and 3 and take the candy with cost 1 for free. So we'll buy these 2 candies. These 2 candies are going to cost $5, right? And then we could take this candy for free because it says we could choose any candy to take away for free as long as the cost of the chosen candy is less than or equal to the minimum cost of the 2 candies. So in this case, the minimum cost of these 2 candies is 2. Since 1 is less than or equal to, in this case is less than 2, which is the minimum of these 2, since 1 is less than 2, then we could get this candy for free, right? It says the total cost of all candies is 2 plus 3 equals 5. This is the only way we can buy the candies. Note that we cannot buy candies with the cost of 1 and 3 and then take candy with 2 for free. The cost of the free candy has to be less than or equal to the minimum cost of the purchased candy. So they're just telling us that we cannot purchase this candy and this candy to get the cost cheaper, because if we purchase this candy and this candy, then the minimum cost between the 2 candies would be 1. And if the minimum cost between the 2 candies is 1, that means we can't get this candy for free because the minimum is 1 and 2 is greater than 1. So if we want to get all of the candies, we have to buy these 2 and then we'll get this one for free. Otherwise, if we just buy these 2, then we won't be able to get this one for free. So that's why we buy these 2, so we could get that one for free. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, the input cost equals an array of integers 6, 5, 7, 9, 2, 2. The output is 23. Explanation says the way in which we can get the minimum cost is described below. We'll buy candies with a cost of 9 and 7. So we'll buy these 2 candies, right? Boom, we'll buy these. Once we buy these, then we could take candy with the 6 for free. So since we're buying these 2 candies and the minimum of these 2 candies is 7, that means we could get this candy that costs 6 for free because it's less than this minimum. Then we can buy candies 5 and 2. So now we're left with this candy and these 2 candies right here. Once we buy these 2 candies for 5 and 2, then we could get the last remaining candy with the cost of 2 for free. So once again, we already bought these 2 and got this one for free. Now we're going to buy these 2, right? Boom. And then we could get this one for free because it says less than or equal to. So in this case, we're looking at the equal to because 2 is equal to the minimum of these 2 candies, right? So this 2 is equal to the minimum of 2, so we can get it. And in total, we got this one for free and we got this one for free. So in total, 5 plus 7 is 12, plus 9 is 21, plus 2 is 23. These are the candies we had to pay for. In total, we had to pay $23. Boom. Now, just in case that didn't make sense, let's take a look at example 3. So example 3, the input cost equals an array of integers 5, 5. This time the output is 10. Explanation says, since there are only 2 candies, we can buy both of them. There is not a third candy we can take for free. Hence, the minimum cost to buy all candies is 5 plus 5, which equals 10. So in this case, we only have 2 candies, right? So, which means we won't be able to get any for free because there is no third one to give for free. So if we want to buy all of the candies, we just need to buy these 2, and we could buy these 2 for 10. So our output is 10, y'all, and boom. Now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we want to do is we want to sort the candy prices in descending order so that the most expensive candies are considered first. So we'll say let sorted cost equal cost dot sorted, put the parentheses, or open up the parentheses, put by, colon, put the greater than sign, and close the parentheses. Now we need to store the final amount that we need to pay, so we declare a variable called total cost, and we'll set that equal to 0 to start. Now we're going to iterate through every candy in the sorted array by saying for I and 0 dot dot sort, sorry y'all, dot dot less than sorted dot count. Then we'll open up, not sorted, but sorted cost dot count, because we want this right here. Boom. Then we'll open up the brackets, and for every group of 3 candies, we're going to pay the first and second candy and get the third candy for free. And since the array indices go from 0 to I plus 1 is used to represent the candy's position in the purchase order, if the candy is not every third candy, we'll add its cost to the total amount paid. So we'll say if, open up the parentheses, I plus 1, come outside of that, mod 3, that means when we divide it by 3, it has a remainder that does not equal 0. So once again, if I plus 1, or parentheses I plus 1, mod 3, exclamation point equals 0. So if I plus 1 divided by 3 does not equal 0, then we'll add the total cost, or the sorted cost, to the total cost. So we'll say total cost plus equals sorted cost, square bracket I. Then we just need to return the minimum total cost after applying the buy 2 and get 1 free discount by coming down here, and we can just say return total cost. Boom, y'all, that should be all she wrote. Let's give it a run, make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I'd like to see, y'all. So, with that being said, y'all, make sure you get one more look at the code. And I hope to see y'all here today. I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.